Okay, this is number 35 on page 314, and it's a pretty easy problem, really. We're just have a coefficient that happens to be the imaginary number, but it's still a number, and so I'm looking at this as a quadratic equation in standard form, and I'm supposed to use quadratic formula to solve it. So a is 1, b is the square root of negative 1, which is just the I, and it's positive, and then c is a positive 2. So we're just going to drop these right into the quadratic formula. So in this case, the variable z is equal to the opposite of b, so the opposite of I, plus or minus the square root of b squared, so I squared, minus 4 times 1 times c, which is 2, all over 2 times a, which is 1. So cleaning this up, under here, the I squared is negative 1, and I'm subtracting 4 times 2, so minus 8. So I'm going to have negative I plus or minus the square root of negative 9 all over 2. Okay, so the square root of negative 9, I'm going to have an I come out and a 3. So I get negative I plus or minus 3I all over 2. So now this is really two solutions here to simplify it, because the negative I and the 3I are like terms. So the plus path, I have negative I plus 3I over 2, which is 2I over 2, which is simply I, 1I. And on the minus path, I have negative I minus 3I over 2, which is negative 4I over 2, which is negative 2I when I simplify it. So it looks like my solutions are a positive 1I and a negative 2I, which are pure imaginary numbers. This is like 0 plus I and 0 minus 2I. Anyway, either of these, if you put them back into the original equation, make it true. And I will leave the checks to you.